Q9. Okay, so part 1 is okay, right? Part 1, where you want to find the acute angle between two planes, all we do is we use the cosine formula. Okay, so given that quick one. Okay, so for question 9, I recall again. First part, you given that P1 is just R dot 1 negative 2 3 0. P2 3 1 2 equals to 0. Okay, so from here the angle between the two normals, right, the cosine of the between the two normals, right, will give you the angle cos theta. So first one, recognize that this is my first normal, this is my second normal, right? So all I do is I take them and then I do my formula. Remember that you need to take mod. Yes. Okay. Okay. So once. Okay. Just show you that it's equals to 60 degrees. Okay. Can This is part 1. Part 2 I don't show. Okay. Part 3, right? Okay. Part 3. Okay. Let me recap first. You all remember part 2? Part 2, right? We need to find the perpendicular distance. Find a girlfriend. Okay. Perpendicular distance. From P to P2. Okay. From P to P2. Okay. Punish those who come late. Don't punish those who come early. Okay. Okay. So P to P2. Okay. So from here, right? Remember that you have managed to find that the distance. Okay. From a point P. This is point P, which is 7 to negative 1, and your origin lies on the plane. You have actually managed to find that this distance is equals to 3 square root 14 over 2. This is from part 2. Okay? So next, right, part 3, we need to deduce the perpendicular distance from P to the line of intersection between plane 1 and plane 2. Okay, so the two planes, right? Okay, so imagine got two planes, plane 1, plane 2. Okay, the line of intersection between plane 1 and plane 2 is here. You can see plane 1, plane 2. P lies here. Okay, so this is the line of intersection. Okay, so we're going to look at it from this side. Okay, so how will it look like? Example, it looks something like this. Okay, you see. Okay, this is like your plane 1. Okay, we're going to look at it from the side view. There are sometimes you draw a side view, okay, but not all the time. Okay, so we don't draw the side view all the time. So this is a plane 1. 1, negative 2, 3 equals to 0. Okay, then you have plane 2. Plane 2, dot product 3, 1, 2 equals to 0. Okay, let's look at this. Remember, okay, you use your part 1 and part 2 to help you. Part 1 tells you what? Part 1 tells you theta is 60. What is theta? Part 1 tells you what? The angle between two planes is 60. Okay, go to part 3. That means what? This is 60 degrees. Okay, so we use this. Some of you use a long method. I think maybe very long. Okay. What else do you know? Where's part 2? What does part 2 tell you? Point P lies on plane 1, right? Correct? What else? Stupid devil. Okay. What else do you know about this? What is this dotted line? What is the dotted line? Yes. So what is the answer for dotted line? It's actually your. Yes. This is from part 1. This is from part 2. So actually the distance here is nothing but 3 square root 14 over 2. So this is from part 2. Okay, from part 2. This part is from part 1. This is from part 1. This is from part 2. Okay? Cannot. Now, we're from here. What are you asked to find? what are you asked to find? Part 3 asks you to find the perpendicular part is a bit misleading, but actually what they really want to find is this. They want you to find this. The line of intersection is here. Can you see? This is the line of intersection. We are looking at the line. We are looking at that line itself, right? This is the distance they're asking you to find. From point P to the intersection of plane 1 and plane 2. The distance from the point P to the intersection between plane 1 and plane 2. We are looking at it from the side. Okay, we are looking at it from the side. Okay, come again? This way, right? Two planes, they intersect at this line, right? This line. Now you look at this. Can you see a point? This is the point. This is the point. So we are looking at the side view. Okay? So I stress again, we are looking at the side view. This is the side view. Okay? So from here, how do we find the green portion? Okay, you know that this is 90 degrees. What can we do? We use Picasso. That's all. You recognize that sine 60 degrees is equals to opposite over hypotenuse, right? So let's say I call this maybe a D. Okay, it's just a 3 square root 14 over 2 divided by D. Okay, simplify, your D should be able to get, anyone found the answer? Square root 42. Okay, that's the general idea. That's the general idea. Okay, that's for part 3. The last few questions I'll be going slower, so I urge you to stay patient because they are quite hard. Okay. Still slow, I still have. Okay. Okay. Then part 4. Given that the point Q 1, negative 1, negative 1, negative 1. Okay. Given that the point Q1, negative 1, negative 1 lies on P2. Find the length of projection of QP onto P2. This is exactly like your question part 2. Okay? Simple, huh? Okay. Given that this point Q, this is your plane 2, this is your plane 2, this is point Q, 1, negative 1, negative 1. Length of projection of QP, P is here, P is 7, 2, negative 1. We want to find this so-called, we want to find the red line. Am I right? What we want. Okay? For part 4. Right? We want this, right? How to find? Yeah, this part 4. How to find? This is PQ. Can I find a direction vector along this line? Do you see a triangle? Yes. Do you see a triangle? Okay, so let's say we go to a triangle. Let's say I tilt this way. I tilt this way. Okay? I tilt this way. This is P. This is. Okay, let's say I tilt this way. I tilt this way. Q. This is P. This one the dotted line. Right? Can you see what is this? What is part? Projection. The projection. Can you see a projection? Can you see a projection? How to see a projection? No, not projection. Yeah, you're looking at the vector component. Okay. You see, let's say this one. Let's say this part I call it A. Correct? Where's the unit vector? Can you see unit vector? Okay. What do you see? Anyone else? Yesterday I buy, then after that LT all rubbish. Here, right? Because, okay, here, right? Of course, I have a vector along this line. Good. I can actually find. So supposedly, if I have this case, so this is our problem. The problem is like that. QP. We have QP, right? Then we have this line. We have this line. Okay. This is the one that we need, right? This is the one that we need, correct? Correct. But can we? So one way is, of course, we have. Suppose we have a unit vector here, a vector here, a vector here. Then this portion will just be equal to A dot B hat. Am I right? Correct? But my question to you is this: do we have a vector along this line? No. Okay, so can we do that? Cannot. Okay. What else? Here got anything or not? Here got anything or not? Here got anything? Yes, we got a normal. We know that the normal is here. Yay! We know the normal is here. What's the normal? The normal is? The normal is 312, right? Is it correct? 312. The normal is 312. Okay? How to get a normal? Because there you can see 312. Okay, so 312. What is QP? QP, we can just take OP minus OQ, which is just 630. Okay, so this is just 630. Alright, I have this vector. They need not be both pointing out, they can be pointing inwards, children. Doesn't matter because we are finding length. Okay, so both pointing inwards. I want to find this one. How to find? Let's say this is my A. Now, this is my A. This one is my B. Correct? My B equals to 312. This one how to find? How to find this length? Now you look at the triangle this way.
Area of triangle.
Area of triangle.
You can find the area using the other divide.
It's just A cos B hat. Okay, can you see? Can you see? I rotate the triangle this way. I rotate this way. Can you see? You look this way. Look this way. Look this way. The light comes here. This is the one lying on the floor. This is the one on top. This is the it can be this way. So I write. I rotate. Rotate. Q E. Can see position. Can see now, right? Can see now, right? Can see So that's why it's not so easy. Okay, so yes, if you ask. Yeah, that's why I ignore him. No, actually, no, you refer to this, right? You know triangles for what? You're trying to find length, you're not trying to find area.
No, but let's say if you want. Because I remember that you said.
That one is A cross B, correct? So that's based on your understanding of the formula. The formula, if it rotates, right, it's okay. In this question, it's a bit tricky. Okay, I draw out the diagram for you. Okay, so this one is plane 2. Okay, Q P is here. Okay, and this is the distance that you want to find. Okay, and here, right, one normal vector that we have, this vector is 312. Okay, and what is QP? QP, right, the direction is 630. Okay, ma? So this is the A, this one is the B, this portion is A cross B hat. Okay, cannot, because I just stupid green triangle this side. This is the opposite side of the two vectors. Okay? Cannot. Yeah. So not easy. Not easy to see, so I go slow. Okay, the rest patient with me. So answer is just stop throwing things at each other. Okay. You don't understand, it's okay, it's not your fault, it's my fault. I never tell you all properly. Okay. OK。明白了吧？OK 哦，模拟上 OK， 会议 OK 啦 OK。宇豪、夫、卓俊 OK 可以啊 OK， video OK， family OK 啊。Okay, this is for PQ9 part 4. It's hard lah, that's why so the main learning point of PQ9 part 4 is your triangle need not always present itself to you in the right orientation. It can be tilted. Okay, it can be tilted. Okay, and it's your duty to it can be tilted. So it's your duty to recognize in the triangle, given these two sides, how is the opposite side related? Okay, and you're always used to find this. Okay, for our distance perpendicular. Okay. I see your copying, so I slow down. Okay. Okay. Then 9. A third plane with equation r dot 2 negative 4 6 equals to 4 is parallel to plane 1. Okay, so let's see. A lot of times you have to draw. Don't draw, cannot see anything. So I say, draw. Okay, this stupid plane. Okay, got like that. Okay, this one is the plane. Plane 3. Maybe I'll draw the plane 3 first. Plane 3, right? I can simplify it to this. I can say this is r dot 1 negative 2 3 equals to 2. Correct? Why? Simply because divide by 2, divide by 2, divide by 2. 1 negative 2 3 divide by 2 equals to 2. So I can write it in this way. 什么？I also don't know, a bit 变态 one. Okay, it's recording. Okay, so sometimes it's like that. Some of this, okay, is parallel to plane 1. So let's draw plane 1 also. Plane 1. Correct? Plane 1. Okay, 1 negative 2 3 equals to 0. Okay? Given the fact, okay, keep quiet, Okay, I want to ask someone this question. Given the fact that in the scalar product form, the right hand side is 0, what can you tell about the plane? I want to ask Ignatius, what can you tell me about this plane? What? The what? Very good, the origin lies on a plane. Okay, so this is one thing. Okay, this is very useful. It always comes out. Okay, PQ9 you always being used. Given the fact is 0, it means origin lies on a plane. Origin lies on a plane. Okay, and alright, you have, suppose I want to find this distance, right? Okay, so maybe let's say it's perpendicular. Okay, can you tell me a vector that is parallel to this dotted line? This dotted line? Direction vector that's parallel to this dotted line. 1 1 no. 1 minus 2 3. Okay, can you see? In fact, it's just simple 1 minus 2 3. Okay, one vector parallel is just 1 minus 2 3. Okay, what does the question want us to find? The projection of, or the distance between the two planes, right? So this is what we're trying to find. Eventually, we're trying to find this, right? This is our part 5, right? Correct? How to find? Same idea. Okay, I'm going to give you a right angle triangle upside down. Okay? A bit disgusting. Okay, this is the part I'm going to show you something new. Okay, so we come up with a point on plane 1. Okay? We come up with a point on plane 1. So let's try to find a point. Try to give me a point. Give me a point that lies on plane 3. Plane 3 or plane 1 is fine, either one. 200. 200? I will go with 200. Is that a better answer? 200 is a good answer because why? Simple lah. 720 also can. Just calculation. So let's say 200 is here. Can, right? And then I use then I can tell, can I say this vector is 2, 0, 0. A bit. Wait, why sorry? Laughing. Why you laugh? Also. Okay, in this case, right, it works because the origin lies on plane 1. Lies on plane 1. Okay? From there, how to find my yellow? How to find this? Okay? Can you see now I got a right angle triangle? Correct? I have one vector, 2, 0, 0. Okay, I go to the side, I show you. I have one vector, 2, 0, 0. I have another vector, 1, negative 2, 3. I want to find this distance, right? I want to find this distance, right? How to find? Top minus bottom. Remember, this is not the full vector. This one is only a vector parallel to this. I ask the question again. Now I have one vector. This vector is 2, 0, 0. I have another. I need to find this distance. Okay? I need this. Okay? I don't know how to find, but I know that one vector that's parallel to this, right, is my normal vector, which is 1, negative 2, 1, negative 2, 3. How do I find my question mark? What's the unit vector? So can you see that to find this, right? To find this, right? All you need to do is this supplies the unit vector. This one project onto this. This is my A. It projects onto this one. Can you see? This one provides a unit vector, right? Okay, let's say I want to find the dotted line. How to find? Not product. Next, how to find this? How to find? Not product. Who dot who? Who dot who? This one dot this one, right? Can you see? The right angle triangle did not present itself in this way. Okay, so answer is just what? So this answer, okay, 2, 0, 0 dot product with 1, negative 2, 3 over 1 square plus negative 2 square plus 3 square. Okay? 可以吗? So with that, answer will just be square root 1407. Okay? This is PQ9. So yes. B1. Can. Either, as long as you can form a right angle triangle, that's okay. So some students do this. Some students form the right angle triangle this way. They form like that. Also can. Also no issue. Some students didn't form the right angle triangle this way. They form this way. Right? It doesn't matter. Okay, it doesn't matter. Okay, Okay. Yeah, lor. Cause I subscribe, I pay. That's all. Yeah. Question 10. Okay, P1 and P2 have the equations 1 x plus y minus z equals to. So quickly, remember I told you the most useful form is to write it in the scalar product form. Okay? 2, negative 4, 1 equals to negative 12. Okay? You have what happened? Don't cry, stand up, sit up straight. 挺着胸做人. Okay. Verify that the vector 1, 1, 2 is parallel to P1, P. This vector here, is it a position or direction vector? It's a position, but the x-axis, we are checking parallel direction. You Okay. Can So here very easy, right? If I want to check that is equals to 2, negative 4, 1. Okay? Your vector
Is there any situation when you got product when you got product
is parallel to the plane. It means that it's perpendicular to the normal. Okay? I say again, if vector is parallel to the plane, this implies that your vector is perpendicular to the normal. Okay, n1 and n2. So we check our vector here 1, 1, 2. We dot product at 1, 1, negative 1. You can see it gives you 0. Our vector 1, 1, 2 dot product with 2, negative 4, 1 gives you 0. So therefore we can say that 1, 1, 2 is, don't write the sign, make sure you write the full word out, perpendicular to both n1 and n2, therefore parallel to both planes. Okay? So must get used to it. Okay, this is a PQ. Okay, after that, find the equation of the plane passes through P perpendicular to P1 and P2. Passes through P perpendicular to plane 1 plane 2. If this plane, if my plane is perpendicular to plane 1, that means, right, is parallel to the so this is my plane, this is my first plane, right? My second plane is somewhere here. So this is my second plane. The normal, this is my normal of the second plane. Okay, suppose these two are perpendicular, right? Plane 1, plane 2 are perpendicular. That means I can say that plane 1 is parallel to this normal. Can right? So can. So very quickly I can say that in my cute little plane, right, is parallel to two things. First one, the normal vector of plane 1, correct? So this plane passes through P. That means it passes through 3, 8, 2. It is perpendicular to plane 1. It means it's parallel to the normal vector of plane 1. Normal vector of plane 1. 1, 1, negative 1. It is also perpendicular to P2. That means it's parallel to the, finish my sentence, the normal vector of P2. So P2 is 2, negative 4, 1. From here, can come up with the equation? Come again? Ask again. Yes, correct. Because my plane, right, is perpendicular to your plane. That means my plane, right, is parallel to your normal. Okay. If I'm perpendicular to you, my plane is parallel to your normal. Don't think about other things. Just yours is never normal. Yours is always a zero vector. Okay. This is one method, okay? So this is method 1. Okay, so actually some of you are very fast. I think Monisha come out with the second method. Okay, this is the first method. So some will leave the answer in this form. Okay? Okay, very good. Okay, I'm very impressed with your thinking. Okay, so you have this. Some will have this. Okay, this is method 1. 3, 2. Oh, sorry. So confusing. Okay, this is the first method. Second method, as some of you realize, is that since in part 1, 1, 1, 2 is parallel to both plane 1 and plane 2. It should be the normal vector of your part 2, right? It should be the normal vector of your part 2, right? So quickly you realize, actually my answer in part 2, I can also write it as 1, 1, 2. Okay, after that, how to find the D? I just take, because it passes through P, right? I just take 382. Okay, very good. Okay, and you will get 15. Huh? Okay, so this is R dot 112 equals to 15. This is method 2. Okay, this is method 1. There are a lot of ways to do it. Some prefer the first, some prefer the second. So up to you all. Okay, because this question, they only say find the equation. They didn't say find in what form. Okay, so if you leave it in this form, you are also right. Or you leave it in this form, you are also right. Okay? My question to you all is this. This equation of the plane. Okay, of the plane, what form is it? I'm going to ask Hui Yi, what form is this? Parametric, a vector in parametric form, vector in scalar product form, or Cartesian form? Okay, very good. Okay, good. Solid lah, Hui Yi. Okay, next. Part 3. Find the coordinates of a point common to P1 and P2. Your P1, this is P1. Your P2, okay, I want to find a coordinates of any point common to P1 and P2. How to find? Okay, one method is I let x equals to 0, right? Okay, very good. Okay, or another method, I can say I let z equals to 0, correct? You let x equals to 0, then you solve. Since this one becomes 0, right? Okay, so you have solved y minus z equals to 0, negative 4y plus z equals to negative 12. Okay, anyone got an answer for this? What's the answer? 0? 0? 044 or 0 negative 044. Okay, okay, what about if I let z equals to 0? Okay, if let z equals to 0, this is what I got. Okay, I got negative 2, 2, 0. Okay, any more methods? Any more method? Yes, use GC lah. Use GC. Just use GC. Okay, you can also let y equal 0. Can also use GC. Okay, can use GC. You are okay? Okay. Can, but this just no the method. No method. Okay? So I have a point, then find the equation of the line of intersection of plane 1 and plane 2. So example, this is your plane 1, correct? This is your plane 2. Okay? You have a point common to plane 1 and plane 2. Where will it lie? You should lie on this line, right? Am I right? So a point should lie here. So your example, just now you all found what? 044, right? 044 should lie here, right? Correct? The point should lie here. The point. The position vector 044 with the point 044 will lie here. Okay? What else? How do I find the direction vector of this line? Liu, I want to find the equation of this brown color line. What do I need? The two normals. How to? You want that line? I want the direction vector of this line. I want to find the equation of this line. These are the direction vector. Right? How to find the direction of this line? Look at part 1. Okay, we always look at a question, right? We do part 4 in part 3 丢掉了. Part 5 and part 4 丢. Look at one question together. Okay, look at part 3, part 1. Any idea? 16. No, I'm asking you.
That's the one. That's like
It's parallel to plane. Okay, so you see, quickly, because in part 1, you know that 112, right? You know in part 1, you know okay, 112 is parallel to plane 1 and plane 2. That means what? Is it parallel to this line? Parallel to this line, right? So I can say. Okay? So equation is just?
0, 4, 4 plus lambda 1.
Yes, thank you. Plus lambda?
Lambda.
Yeah, lor. Okay? Can This is for part 3. This is for part 3. So I'll continue on Friday.